Hello everyone. This is the second lecture on the first outcome, which is your DC circuit. In the last lecture, we have already discussed about some of the parameters of an electrical circuit, such as charge, current, EMF, and potential difference. Also, we have discussed about Ohm's law. Now, Ohm's law, we all know that it is given by this equation: voltage is equal to current multiplied by resistance. Now, so this Ohm's law, it states that the current I is directly proportional to the voltage and inversely proportional to the resistance for a uniform wire at a constant temperature. Okay. We have also discussed about series and parallel circuits. Now, for a series circuit where you have several resistances, let's say R1, R2, and R3, connected something like this, and you have a voltage source which is supplying, or a EMF source which is supplying some current I to all these resistances. So this is called as your series circuit. And for a series circuit, the value of potential drop or voltage drop across each of these resistance will be different. But the value of current flowing through all these resistances will be same. Similarly, if you have the same resistance or a different set of resistances which are connected in parallel, so if we connect several resistances in parallel, they would look something like this. Something like this. And obviously you will have a voltage source. So since we are talking about DC circuit, so this voltage will be a direct current source. So if the circuit is complete, some current will start flowing in this circuit. Now for a parallel circuit, the value of current flowing through each of these resistance will be different. Whereas the value of voltage appearing across each of these resistance will be the same. Okay. Now for a series circuit, if we have to calculate the equivalent or the total resistance, we represent it by RT, and this is equal to simply the sum of the three resistances, or the sum of all the resistances connected in series. So here we have three resistances connected in series: R1, R2, and R3. Okay, so we have three resistances, they are connected in series. So its equivalent or total resistance will be simply the sum of these resistances. Now to find the equivalent or the total resistance of a parallel circuit, we can use this relation, that is 1 over RT is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. Okay, so essentially it is the sum of reciprocals of the resistances. Also, you should note that the total resistance is 1 over RT. So after you have calculated it, don't forget to take the reciprocal of the value of the resistance which you have calculated. Okay, now let's continue our discussion and let's try and calculate the total resistance of this circuit. Now in this circuit, as you can see on your screen, let's read the question. So it says find the equivalent resistance RT for the following circuit. Also determine the voltage drop across each resistor. So as we can see, R1, R2 and R3, they are all connected in series, and we are required to calculate the total resistance or the equivalent resistance, and also we have to find the potential drop or the voltage drop across each of these resistances. Let's see how we can calculate this. So here I have done some calculations. Now since the resistances, they are connected in series, so we can use this relation, that is the sum of the three resistance will be its total resistance or equivalent resistance. So RT will be equal to R1 plus R2 plus R3. Now R1 is 1 kilo ohm, R2 is 5 kilo ohm, and R3 is 10 kilo ohm. So we simply add them together because they are connected in series. So altogether we will get 16 kilo ohm. Now to find the current flowing through each resistor, essentially for a series circuit, the current flowing through each of the resistance will be the same, that is equal to your supply current. So the same current will flow through R1, also the same current will flow through R2 and also through R3. Now to find the value of current, what we have done here is I have redrawn this circuit and replaced the three resistance by its equivalent resistance or total resistance, right? As I have mentioned before also, that the reason to calculate the total resistance is essentially to replace them or to reduce our circuit, right? So here what I have done is I have simply replaced the three resistance by its equivalent or total resistance, which is 16 kilo ohm. And this 16 kilo ohm resistance is connected to the 5 volt supply, same as the original circuit. Now if we consider this equivalent circuit and use Ohm's law to calculate this unknown, this current, we can do that by using this or modifying the Ohm's law a little bit, modifying the equation of Ohm's law a little bit. So the current I will be equal to the supply voltage V divided by RT, the equivalent resistance. And if we put in the value, the supply voltage is 5 volt and the equivalent resistance or the total resistance is 16 kilo ohms. So we have voltage in we have the EMF or the supply voltage, it is in volts, whereas the total resistance is in kilo ohms. So there is a difference in the unit, so we have to convert this kilo ohm into ohms. So what I have done is I have multiplied 16 multiplied by 1000 in the denominator here, right? So if we do the calculation, we'll end up getting 0.3125 milliamperes. Okay, so this is the current which is flowing in the circuit, right? Now if I can use a pen, so this is the current which is flowing in the circuit, which is 0.3125 milliamperes. Now the same current will flow through all the resistances in the circuit because they are connected in series. Okay. Now the next step or the next part of the question is that we have to determine the voltage drop. Now again, using Ohm's law, we can calculate the voltage drop across. So if this is plus, this is minus, this would be, yeah, this would be plus and then minus. Because the current flows from higher potential, which is your positive, towards the lower potential, which is represented by the negative sign. So we can find out the voltage drop using Ohm's law, right? Let's say V1 is the voltage drop or the potential drop across R1, V2 across R2, and V3 is across R3. So simply using Ohm's law, we can calculate V1 will be equal to I multiplied by R1. Okay, and if we do the calculation, the current I, it is 0.3125 milliamperes, or it will be 0.3125 multiplied by 10 to the power minus 3 amperes. So if we put this value of current I here multiplied by resistance, so R1 is 1 kilo ohms. Again, this is in kilo ohms, so we have to convert it into ohms. So I have multiplied here by 1000, and if we do the calculation, we'll get 0.3125 volts. Similarly, V2 will be the current I multiplied by the second resistance, because the same current is flowing through the second resistance. They are connected in series. So if we do the calculation again, we will end up getting 1.5625 volts. Similarly, V3, it comes out to be 3.125 volts. Okay, so now I have drawn the circuit on multisim, the same circuit. Okay, so if we run the simulation, so I've connected the 5 volt, and you have 3 resistances. R1 is 1 kilo ohm, then R2 is 5, and R3 is 10 kilo ohms. So let's see what happens here if we run the circuit. So if we run the circuit, you could see the voltage. The voltage drop across R1 is 312.50 milliamperes, and in the circuit also, or in our calculation, we also got this value, right? we actually got 0.3125 volts, which is, if you again multiply it by 1000, you will get 312.50 millivolts. If you multiply it by 1000, you will get in millivolts. Okay. Similarly, the voltage drop across R2, it is about 1.5625, right? The same value which we have calculated. And similarly, the voltage drop across R3, it is 3.125 volts, right? Now, I want you to notice something here. So if I add all these values, if I add all the voltages, it comes out to be equal to 5 volt, which is my supply voltage, right? So this is something called as your Kirchoff Voltage Law. So we'll discuss that in a few moments from now. But that is called as your Kirchoff Voltage Law, or KVL. Now, if I could measure the current in this, so let's stop the simulation, and now if I put in the ammeters here, so let's find out what is the current flowing through R1, then again what is the current flowing through R2. So we'll place a probe there, and then what is the current flowing through R3. Okay, so let's see, it should give us the value of current, and hopefully if it is visible, its value is 312.5 microamperes, and it is the same current is flowing through all the three resistance. Through R1 also it is 312.5 microamperes, through R2 also it is 312.50 microamperes, and through R3 also it is 312.50 microamperes. So basically, for a series circuit, as I mentioned, the same current, or your supply current, will flow through all the three resistances. And if we look at the calculation, we got the supply current to be 0.3125 milliamperes, and if we do the conversion, that is again multiply it by 1000 to convert it into microamperes, because we got the value in milliamperes. If we convert it into microamperes, it is 312.50 microamperes, right? So again, if we look at the value, I was talking about this value, the current which we calculated, right? We got it in milliamperes, and the value which we are getting in the simulation, it is coming out to be in microamperes. Okay, so this is all about your series circuit. Now similarly, let's take another problem on parallel circuit. So here you have this circuit. Now if you look at the circuit, obviously R1, R2 and R3, they are connected in parallel, right? So for a parallel circuit, the voltage will be the same across each resistance, whereas the current through each resistance will be different. Okay, so now let's have a look at the calculations. Okay, so first thing which we have to do is we have to find out the equivalent resistance, RT, right? And since the resistances, they are connected in parallel, so I will use this relation, that is 1 over RT is equal to 1 over R1. R1 is 1 kilo ohm plus 1 over R2. R2 is 5 kilo ohms plus 1 over R3. R3 is 10 kilo ohms. So I've used that relation and simply substituted the value, did the calculation. Now here I've done some calculations, but if you prefer to use your calculators, you can do that, right? You will get your value in decimals, ultimately the same thing, similar around 0.769. But if you prefer to use your calculator for doing these calculations, you can do that. Okay, right. So if you do the calculation, you get 13 divided by 10. Now again, I'll remind you, this is 1 over RT, that is reciprocal of the equivalent resistance. Now in the question you are asked to calculate the equivalent resistance. So we have to take the reciprocal of this value, right? We have to reverse it. So RT will be 10 divided by 30, which will come out to be 0.769 kilo ohms. That will be your equivalent resistance. Now again, I have redrawn the circuit and replaced the three resistances connected in parallel by its equivalent resistance or by its total resistance, right? So I have to calculate the value of current or the supply current, basically the total current which is flowing in this circuit. So for that, so we have to calculate the total current. Okay, so just let me use a pen. Okay, so the current I, it is flowing in this circuit like this, right? So until here the current I will come, but at this first junction the current will get divided into two parts. So let's call this one as I1, and the remaining current will flow through this path. Again, at the second junction, the remaining current which is coming, it will again get divided into two parts. So let's call this one as I2, and again it will flow, whatever is the remaining current, it will flow through I3. It will flow through R3, and we are calling it as I3. Okay, so at the moment we are calculating the supply current or the total current I. Okay, so again we are using Ohm's law. So the current will be voltage divided by resistance, and here it will be the supply voltage V divided by the total resistance or the equivalent resistance, right? So we simply substitute the value and do the calculation. So the value, or after the calculation, the value, it comes out to be 6.5 milliamperes. Okay, so the value of this current I, it came out to be 6.5 milliamperes. Okay, now if we, now for a parallel circuit, the value of current is different. Actually, I've mentioned it in the other way around. The value of current is different and the value of voltage is the same, right? So let me correct that. So the value of current is different and the value of voltage is same. right? So the voltage across R1, the voltage across R2 and the voltage across R3, they all will be the same, that is the same as your supply voltage. However, different amount of current will flow through each of these resistances. Okay, so we have to find the value of current flowing through each of these resistances. So I1, again using Ohm's law, we can use I1 will be equal to voltage, that is your supply voltage, divided by R1. Now the supply voltage is 5 volts, whereas the value of resistance is 1 kilo ohm, right? So we have to convert it in ohms. So that is why I have multiplied it by 1000, right? So if we do the calculation, we'll end up getting 0.005 amperes, or we can write it as 5 milliamperes. That is the value of I1. Similarly, I2, if we do the calculation, that is your voltage divided by R2. Again, don't forget to convert this 5 kilo ohms into ohms. So I have multiplied it by 1000 here, right? So it came out to be 1 milliampere. And the same way, I have not shown it in the slide because there was no space here. But if you do the calculation yourself, the value of I3, it will come out to be 0.5 milliamperes. Now, if you look at the three values of the current, if we add them together, so 5 milliamperes plus 1, it is 6 milliamperes, and plus 0.5, it will be 6.5 milliamperes if we add all the three currents, or all the currents flowing through each of these resistors. If we add them together, it will come out to be 6.5. And if you look at the value of the supply current, it is 6.5 milliamperes, right? So we'll try to define the law, but essentially it is called as your Kirchoff current law, right? So again, let's have a look at the parallel circuit. So again, on multisim, I have just connected these resistances in parallel. The same circuit I've drawn it here, and if we run it, so the first thing what we can see is the voltage. So if we look at the voltages, voltage drop across R1 is 5, across R2 is also 5, and across R3 is also 5. So for a parallel connected circuit, the value of voltage drop across each of the resistance is the same, and it is equal to your supply voltage. Okay. Now, if we look at the value of current, it is 6.5 milliamperes. So let's stop the simulation, and now let's try to connect the ammeter here to find out how much current is flowing in the first branch. And let's copy it from here, and then maybe here. Now if we again run the simulation, the value of voltages is the same. The value of current in the first branch, or the value of current flowing through R1, it is 5 milliamperes, and the value of current flowing through R2 is 1 milliamperes, and the value of current flowing through R3 is 500 microamperes, or we can say 0.5 milliamperes. So if we add them together, so 5 plus 1, 6 plus 0.5. So altogether it comes out to be 6.5, which is the supply current, right? So for a parallel circuit, the value of current is different and the value of voltage across each resistance is the same. Okay, now again let's move back to the slides. Right, so let's now define Kirchoff voltage law and Kirchoff current law. So Kirchoff voltage law, or in short KVL, uh, it says that the voltage drop in a series circuit, right? So in a series circuit will always be equal to the voltage applied. So the voltage drop, something like if you have this type of circuit here, so the voltage drop, right, you have two voltage drops here, one across R1 and the other one is across R2. So V1 and V2 are your voltage drop, and this is a series circuit. So the voltage drop will be equal to the voltage applied, that is your Vs. So if you add the voltage drop in a series circuit, it should be equal to your supply voltage. That's what your KVL says, or it states. Similarly, Kirchoff current law, or KCL in short, it says that the algebraic sum of the current at a junction will always be 0. Or in other words, we can say that the total current flowing in should be equal to the total current flowing out of a junction, right? So if we look at this figure here, we have I1, I2 and I3 which are flowing in the junction, into the junction, and I4 and I5 are flowing out of that junction. Okay, so as per the statement which is mentioned here, the algebraic sum, if you add all the currents together, it should come out to be 0, right? Now don't get confused by all the plus signs here. So by convention, we consider the current flowing in as positive and the current flowing out as negative, right? So I4 will be a negative value because it is flowing out, right? Similarly, I5 will also be a negative value because it is flowing out of from that junction, right? So obviously, if you add them together, it will come out to be 0. Or we can say that the sum of current flowing in should be equal to the sum of current flowing out. That means I1 plus I2 plus I3 should be equal to I4 plus I5. Okay, so whichever way you want to state this law, you can mention it. Now let's look at this question. So the question says that we have to find the value of current and the voltage drop across each resistor in the following circuit and verify using Kirchoff Voltage Law, or KVL. Now if you look at the solution for this question, now the first thing to verify, we have to find out the value of current and voltage drops. The first thing which we have to do is we have to find the value of current I and V1 and V2, which are the voltage drops. Okay, now to find the value of current, first we have to find the total resistance. So for that, since this is a series connected circuit, so it is simply the sum of the two resistances, that is RT is equal to R1 plus R2. R1 is 6 ohms and R2 is 4 ohms. So the sum will come out to be 10 ohms. Okay. So the sum, it comes out to be 10 ohms. So again I have for visual reference, again I have drawn the equivalent circuit. So again I have replaced the two resistance by its total resistance or its equivalent resistance and redrawn the circuit. Now this current I, can be calculated by using Ohm's law, which is your supply voltage divided by the equivalent resistance. So the supply voltage is 20 volts divided by equivalent resistance. We have just calculated, it is 10 ohms. And if we do the calculation, it comes out to be 2 amperes. Now since the resistances, they are connected in series, so the same value of current will flow through each of these resistances, right? So the same value of current I will flow through R1, and again the same value of current I will flow through R2. Okay, so we have found the current flowing through each of the resistances, and that came out to be 2 amperes. Okay. Now the next thing which we have to do is we have to find the voltage drops. To find the voltage drop, we can again use Ohm's law, and V1 will be equal to I, the current, multiplied by R1. So it is 2 multiplied by 6, which comes up to be 12 volt. Similarly, V2, again we can use Ohm's law, and it will be current I multiplied by R2. And R2, this time it is 4 ohms, right? So if we do the calculation, it comes out to be 8 volts, right? So we have also found the voltage drop across each of these resistances. Now further in the question, it says verify using Kirchoff Voltage Law. So what we have to do is, let's use Kirchoff Voltage Law. So it states that the sum of the voltage drop across or the sum of the voltage drops in a series circuit is equal to your supply voltage. So let's try and verify that. So the sum of voltage drop, that is V1 plus V2, should be equal to your supply voltage Vs. So if we add them together, 12 plus 8, it is 20 volt, and that's my supply voltage, right? So we have verified that. Now let's look at this next question. So again in this question also we have to find out the value of current and the voltage drop across each of the resistors, and also we have to verify this using Kirchoff current law this time. So Kirchoff voltage law is for series circuit, Kirchoff current law is for parallel circuit. Okay, now let's look at the calculations here. Okay, so since this is a parallel connected circuit, so we have to use this relation, 1 over RT is equal to 1 over R1 plus 1 over R2, right, to calculate the equivalent resistance. So let's substitute the value. It will be R1 is 2 and R2 is 4. So if we again do the calculation, we'll get 3 over 4. Now this is your 1 over RT, so we have to take inverse of it. So RT, it is equal to 4 divided by 3, and it is in decimals, it will come out to be 1.334 ohms. Okay. Now since the resistances, they are connected in parallel, so the amount of current flowing through each of these resistance will be different, whereas the voltage across each of these resistance will be the same, and it will be equal to your supply voltage here. Okay. So the voltage drop across R1 and R2 will be equal to 2 volts. Okay. Whereas let's calculate the value of current. So if we calculate the value of current I1, which is flowing through R1, using Ohm's law, we can calculate this. So it will be equal to your supply voltage divided by R1. So supply voltage is 2 volts and R1 is 2 ohms. So if we do the calculation, it comes out to be 1 amperes. Similarly, if we calculate I2, the current flowing through the second resistance R2, it will be your supply current, a supply voltage divided by the resistance R2. Supply voltage is the same, 2 volt, divided by the R2. R2 is 4 ohms. If we do the calculation, it comes out to be 0.5 amperes. Now we have to verify using Ohm's law. Verify using KCL. Right? Now if you look at this junction over here, according to KCL or Kirchoff current law, the value of or the amount of current flowing in a junction should be equal to the amount of current flowing out. So I1 and I2 are flowing out of this junction, and their sum should be equal to your supply current I. Okay. So supply current, again using Ohm's law, and since we have already calculated the equivalent resistance, I have just briefly calculated it. So it will be the supply current, this one. Okay, it will be Vs divided by the equivalent or the total resistance. So 2 divided by 1.334, and it comes out to be approximately equal to 1.5 amperes. Now if we add the current I1 and I2, so I1 is 1 and I2 is 0.5, so that sum of the current will be 1.5, which is equal to your supply current, right? So hence KCL also we have verified this using KCL, that the amount of current flowing in is equal to the sum of current flowing out of that junction. Now, so the next thing which we have to discuss is about voltage division rule. So we have already studied about Kirchoff Voltage Law, right? And we also know about Ohm's law. So basically, if we have to calculate the potential drop V1 and V2, we can do that using Kirchoff Voltage Law and Ohm's law. But if you follow that process, it will be a bit lengthy, right? So using the same relation, they have developed voltage division rule, right? And what it says that the voltage distribution for the circuit shown in the figure is given by V1 is given by R1 divided by R1 plus R2 multiplied by the supply voltage. So we have a direct relation to calculate the voltage drops. So let's say if we have to calculate the voltage drop across R1, that is your V1. So what we have to do is we have to use the first relation, this one, and it says R1, that is your R1 divided by R1 plus R2, the sum of two resistances, multiplied by the supply voltage V. Similarly, if we have to calculate V2, that is the voltage drop across R2, what we have to do is we have to divide R2 divided by the sum of the resistance multiplied by the supply voltage, right? So this way we can directly calculate the value of voltage drop without using the entire process of using KVL and then applying Ohm's law in the middle, right? So it's a kind of a shortcut. So in the exams or in your assessments, if you are not asked, or if in the question it is not mentioned that you have to use voltage division rule, if it is not specifically mentioned, then you can use your KVL, Ohm's law, or even voltage division rule if nothing is mentioned. But if it is mentioned that you have to calculate V1 and V2 using voltage division rule, so you have to use this equations which are on your screen. Now if you would have noticed, we in this formula, we basically, if we have to calculate the voltage across R2, right, so R2 is on the top or in the numerator divided by the sum of the resistances and multiplied by your supply voltage or your supply current, right? Now if you have to calculate the voltage across R1, then R1 will be at the top divided by the sum of the resistance multiplied by the supply voltage. So that's a small thing over here, because the next law which we will discuss is your Kirchoff current law, and in that it will be slightly different, right? So anyways, we have to use this voltage division rule over here, and let's take a question based on this. Now in this question we have to determine the value of voltage shown in the figure below using voltage divider rule or voltage division rule. So it is specifically mentioned, so I have to use voltage division rule. I cannot use Ohm's law and KVL to calculate the value of voltage, right? So let's have a look at the calculations. It's quite simple. Let's call this 50 volt, which is your supply voltage, we call it as V in, that is your input voltage. Let's call it V in. And we have two resistances over here which are connected in series, right? So since we have to calculate the value of voltage across 6 ohm, so 6 should be in the numerator, or it should be in the top, divided by the sum of the resistances. So you have 4 and you have 6, so 4 plus 6 multiplied by V in, or your supply voltage, right? So if we substitute these values and do the calculation, the voltage across the 6 ohm resistance, it comes out to be 30 volts. Okay. Now let's talk about current division rule. So again, current division rule is an extension of your Kirchoff current law. Okay, so it is an extension of your Kirchoff current law, and it is kind of a shortcut to calculate the current in, or the current flowing through each of the resistances, these I1 and I2, right? So For a two branch parallel network, something like shown in this figure, the value of current I1, it will be equal to R2 divided by R1 plus R2 multiplied by the supply current. Now here in these two equations, if you notice, if I am calculating the current I1, that is this current, I am using the other resistance R2. So R2 is on the top, divided by again sum of the resistances multiplied by the current. So again, current division rule, it is the relation, its relation is in terms of current and resistances. And for voltage division rule, the relation was in terms of voltages, that is your V1 and your supply voltage. Okay, the main difference over here is this one. If you are calculating I1, you should consider the second resistance. Similarly, if you are calculating I2, you should consider R1. So R1 should be at the top, divided by the sum of the resistance R1 plus R2 multiplied by the supply current. Okay. Now again, let's quickly go through this question. So again, in this question, we have to calculate the value of current, that is your supply current I, the current flowing through each of these resistance, that is I1 and I2, in the following circuit using current division rule. Okay, so it is specifically mentioned that you have to use current division rule. So you cannot use KCL or Ohm's law to calculate these value of currents, right? Because it is specifically mentioned. Now let's quickly go through the calculations here. Now, to find the value of supply current, first of all we need to find the equivalent or the total resistance of this circuit. So since the resistances, they are connected in parallel, so we can use this relation over here, that is 1 over RT is equal to 1 over R1 plus 1 over R2. Now R1 is 2 ohms and R2 is 4 ohms. So if you do the calculation, 1 over RT will come out to be 3 divided by 4. So RT will be 4 divided by 3. And if you do the calculation, it comes out to be 1.334 ohms. Now since we know the value of equivalent resistance and we also know the supply voltage, which is 2 volt, we can calculate the value of supply current. So this supply current I will be equal to your supply voltage V divided by the equivalent resistance or the total resistance. So it will be 2 divided by 2 is your supply voltage and divided by 1.334, and it comes out to be approximately 1.5 amperes. Okay. Now using current division rule, so we cannot we have to calculate the value of current using current division rule, right? Now for current division rule, let's first calculate the value of current I1, which is flowing through R1. So I1 will be equal to R2, the second resistance should be at the top, divided by R1 plus R2 multiplied by the supply current. Now if we substitute the value and do the calculation, it comes out to be 1 ampere. Similarly, if you calculate I2, your R1 should be at the top, right? So R1 divided by R1 plus R2 multiplied by the supply current. Again, substitute the value. R1 is 2 ohms, R2 is 4 ohms, right? And the supply current, we have calculated it. It is 1.5 amperes. So if we do the calculation, it comes out to be 0.5 amperes. Now again, if you want to check your answer, you can, if you remember, the value of supply current should be equal to the sum of the current I1 and I2, right? So the amount of current flowing in a junction should be equal to the amount of current flowing out from that junction, right? So you can, using KCL, you can just verify your answer whether it is coming out to be the same or not. So if we add I1 and I2, so 1 plus 0.5 is 1.5 amperes, and it's the same as your supply current I. So therefore my answers, they are correct. So you can use these small tricks to verify your answers even in your assessment. Now, the last thing which we have to discuss for this unit or for this outcome is your electrical power and energy. Now, when a direct current I amperes is flowing in an electrical circuit and the voltage across the circuit is V volts, right? So let's take a circuit. So if we have some circuit, maybe something like this. So if some current I is flowing through this circuit and the voltage which you have connected is V, power in watts is given by voltage multiplied by the current, right? So power is simply the multiplication of your voltage and current. Okay, now you can develop two more equations using Ohm's law here. So if we replace V in this equation by IR, we can modify this and write another equation of power as I square R. Similarly, if we replace I in the main equation or in the first equation by V over R, we can get a third equation for power, which is V square divided by R. Now the unit of power is watts. Okay. Now electrical energy is simply if you multiply your power with time. Okay, so that's your electrical energy, and the unit which we measure the electrical energy is joules, or sometimes we also use kilowatt hour. So kilowatt hour, it is your generally I think the power or electricity in the home, they are measured in kilowatt hour. Okay, so again since electrical energy E is equal to power, now power is V multiplied by I, your voltage multiplied by current, and energy is power multiplied by time, so it will be VIT. Again, if you replace V in the first equation, you can get I square RT, and similarly if you replace I using Ohm's law in the first equation, you can get V square divided by R multiplied by T. So you can get these three equations. Now let's use these equations to do some or solve a question. Now in this example, an electric fire takes 8 amperes from a 230 volt supply. calculate the power dissipated and the resistance of the fire element. So basically in this question you have a electrical heater or electric fire, right, which is being supplied by 230 volt, right, voltage or EMF, and as a result 8 amperes of current is flowing through this electrical heater, and we are required to find the power dissipated or power consumed, right. So power is your voltage multiplied by the current. So the supply voltage is 230 volt multiplied by the current flowing through it is 8 amperes. So if we multiply them together, we will get 1840 watts or 1.84 kilowatt. In the next part of this question, we have to find the resistance of the fire element or the heating element, we can say. So to find the resistance of the heating element, we will use Ohm's law. So resistance will be equal to voltage divided by current, and the supply voltage is 230 volt, and the current flowing through this heating element is 8 amperes. So if we do the calculation, it comes out to be 28.75 ohms. Similarly, let's take another question. Now in this question, let's read the question first. An electric underfloor heating system has a resistance of 48 ohms and is supplied at a voltage of 230 volt. So you have to calculate the power input, the energy supplied in kilowatt if the system is on for 8 hours, and you also have to calculate the energy supplied in joules. Now for your hint, I have given the conversion. So 1 kilowatt hour is equal to 3.6 multiplied by 10 to the power 6 joules. Now let's look at the calculations quickly. So in the first part, so basically this is your underfloor heating system, which has a resistance of 48 ohms, and you have connected it through a 230 volt power supply, okay, and as a result of which some current will be flowing in this circuit. We don't know this because it's not given in the question. Now to calculate the power is your voltage multiplied by current. So we know how much amount of voltage or EMF we have applied, but we still don't know the value of current. So to find the value of current flowing through this underfloor heating system, we will use Ohm's law. So Ohm's law, to calculate the current, it will be supply voltage divided by the resistance. So supply voltage is 230 volt divided by your resistance is 48 ohms. Right? If you do the calculation, it comes out to be 4.792 amperes. Now to calculate the power, we have all the values. We have calculated the value of current. We already know the value of voltage. So let's multiply them together, and it comes out to be 1.102 kilowatt. Okay. Now for the second part, we have to calculate the energy supplied in kilowatt if the system is on for 8 hours. So if this system is on for 8 hours, how much amount of energy will it consume in kilowatt hours, right? So energy is simply your power multiplied by time, and since we have to calculate its value in kilowatt hours, so the power, the unit of power, if it is in kilowatt, or basically it should be in kilowatt, right? So we have already calculated its value in kilowatt. It is 1.102, and time, this time should be in hours. Okay, so it is already given as 8 hours, so let's multiply them together. So 1.102 kilowatt multiplied by 8 hours, it will come out to be 8.816 kilowatt hours. Okay, now in the last part we have to calculate the value of energy supplied in joules, right? So it is often beneficial to remember this. I'm not too sure if it will be given in the formula sheet or not, but if you remember this, it will be convenient probably. So 1 kilowatt hour is equal to 3.6 multiplied by 10 to the power 6 joules. So we have already calculated the value of energy in kilowatt hour. If you multiply it by 3.6 multiplied by 10 to the power 6, which comes out to be 31.8 multiplied by 10 to the power 6 joules, or 31.8 megajoules, right? So this underfloor heating system, if you operate it for 8 hours, it will consume these many 31.8 megajoules of energy, or 8.816 kilowatt of energy. Okay, so probably this was, I think, all the things which we have to discuss. Yes, so that was it. Thank you so much. So this outcome is complete. In the next class we'll discuss, or we'll take some tutorial questions. Thank you so much.